So welcome again to the last part of this hypsometric analysis series. So today, in this video, we are going to learn about the calculation of hypsometric integral using digital elevation model. Okay, so what we are going to do here, we require first one plugin. So for that, we will go to plugins, manage and install plugin, and here in your installed plugins, you have to make sure that you have this processing saga next gen provider. And if you do not have this particular plugin, I will put a video a link on the description box from where you can check the video and learn how to install this plugin. Okay, so you require this plugin for this analysis. So I'll close this for now, and in my processing toolbox I will search for focal statistics. Okay, focal statistics in Saga NextGen plugin. Okay, so we'll double click, and the grid that we are going to use will be, of course, our drainage basin DEM. Okay, so our window will be of square shape. Okay, so the window for which the type of window for which you want to do analysis, so that will be square in shape. Okay, so we will keep everything as it is, and then here we have so many parameters that we can calculate. Okay, but we do not want all the parameters, so I will uncheck all these boxes here from the bottom. Okay, and if you want some of these parameters, then you may use focal statistics. Okay, so this, okay, we require maximum value, we require minimum value, we require mean value of DEM. Okay, and then if you want distance weighing, then you can use one of these methods. We do not want any distance weighing for this. I'll just click on run. It will take some 1 minute maybe. So our task is complete. Now we will close this window. So what we have got, first we will understand that, so this is the mean value of the elevations. Okay, so what this focal statistics has done, it has taken the square shape 4 by 4 pixels, okay, 4 by 4 window, and has taken mean for it and given it to the first pixel. Okay, then it has moved from left to right. In the same way, it has calculated all the pixel values, all the mean pixel values for our DEM, right? So that means for every pixel we have the mean value. In the same way, it has calculated minimum value, and in the same way it has calculated our maximum values. Okay, if you will close this on this, you will see the difference in the DEM, right? So now why we have calculated this, because if you remember the formula of hypsometric integral, it calculates from the mean value minus sorry, the mean value minus the minimum value divided by maximum value minus minimum value. Okay, so now we have 3 DEMs for which we can calculate hypsometric integral, using which we can calculate hypsometric integral for our entire drainage basin using digital elevation model. Okay, so for that we require raster calculator. So I will go to raster calculator. Okay, so we are going to use this raster calculator here. So we will select the input DEMs, mean, maximum and minimum. Click on OK, and then write the expression here. So our expression will be brackets open, mean value minus minimum value, brackets closed, and then divided by brackets open, maximum value minus minimum value, brackets closed. Okay, click on OK. And if you want to set any of these, you may, but that's okay for now. We'll run and close. Okay, so this is the DEM which shows us the distribution of spatial distribution of our hypsometric integral in this area. Okay, so we will use the layer styling panel to see the values. You see our minimum value is 0.04 and our maximum value is 0.09, and we will see at what places this exactly is. Okay, so all our lower values are near the river valleys. Okay, so um let me invert the color ramp. Okay, and we can also use uh, the distribution of the values in order to see what are the maximum and minimum values, or the range in which our maximum and minimum values varies. Okay, so I'm going to put my maximum limit at this point so that I can see all the distributions properly. Okay, and here I'm going to use 0. Let's say 1. Okay, 0 0.1 to 0 0.759, or let's say 0 0.75 or 76. Okay, so this is how our HI distribution maps can be prepared, and you can see where the high values are. Okay, these high values, and then you can compute it with some base layer. For example, if you have the layers of different spatial distribution of geological formations, rocks, and maybe some faults. Okay, if you have any sort of geological information from that area, any geomorphological information from the area, then you can compare the distribution of HI values with them and conclude on the landscape evolution and what are the reasons behind the distribution, or the presence of such a landscape in this area. Okay, or if there is any anomalous value or any pattern you can identify in this area, in a particular area. Okay, so this is how your HI index maps can be calculated. If you want, you can also put filter to, let's say, 0 0.2. Okay, and see the distribution how it is looking. I think 0 0.1 was fine, but here we can go up to 0 0.7 or just 0 0.7. Okay, okay, so this is how you can put different filters to your raster maps, and this principle applies to all the raster maps, raster designing you can do in QGIS. Okay, so I'm going to collapse this, and let me close this. And here what we can do, we can multiply it with the base layer. Okay, and drainage basin here. So I'm going to put that as hill shade, and then so that you can see the distribution of elevation in the base map, right? So here you see the elevation is higher, so that is why I mean that can be one of the reasons, and you can also find out why the elevation is higher. And in the valleys you have lower values of HI, and in the higher peaks or the elevated lands you have higher values of HI. Okay, again you have to set up the comparison between different layers of data that you have, then only you can conclude something. Okay, that and why you have higher values here, you have to identify based on the different parameters, different factors that are affecting the landscape evolution in this particular area. Okay, so this can be your final map of HI distribution. Okay, so I hope these videos on hypsometric analysis was helpful and was clear. If you have any doubts, kindly send me that on the email ID. I will provide the email ID in the description box, and it will also be reflected in the video. Okay, so write me your comments and write down the comments in the chat box as well if you have any query. And thank you for watching the videos. and do let me know if there is any other morphometric parameter which you want to learn and you want me to make videos on it. And okay, so thank you so much, and don't forget to subscribe the channel and press the bell icon. Share these videos with your friends who are in need of learning morphometric analysis, as this is one of the powerful analysis that you can do when you are doing any sort of projects related to landscape evolution, or where the land is involved. Okay, so all these videos based on GIS analysis will be useful for them, whether they come from academics or whether they come from the some industrial part. Okay, they are doing some industrial projects, so all these videos will be helpful for them. So thank you for everyone. See you in the next video.